So we've just heard from SGI, who's had techniques in powering down drives to extend the reliability and the life of the drives, and Dave Anderson, who's looking towards the future and directions that we might want to go or that would benefit how we store data, and we can move it faster and speed up our applications that are going to be using it and leveraging the data and getting it to these applications faster. Now we're going to take a look at the present, and we're doing this by bringing some folks from today's world who are, and the two people that we're bringing up are from Shutterfly. Mike Kugler is going to be speaking next, and then we have a gentleman from Backblaze who is going to touch on what they're doing and sit on our panel in a few minutes to talk about how they're leveraging hard drive technologies to store data today. So I yield to Mike. Thank you. Oh, I have to find you're here. Do you want the slideshow?
Sure.
That good?
That's good. Hey, everybody. You guys hear me okay? So, let me back up. My name is Mike Kugler. I work at Shutterfly. Hopefully some of you folks have heard of them. I live at the other end of the street from most of you guys. I am in the customer space. I'm a commercial customer. I go and buy the cool stuff that you guys invent and tweak and market and research on. So my mandate is to find things that are useful for Shutterfly's business and use them. So I have very different focus than some of the other folks around. So here's me. I've been at Shutterfly for 6 years, 2 years managing the group. Before that, as one of the storage engineers. Before that, several years at eBay working on SAN storage. And before that, and along with that, lots and lots and lots of gigs as a sysadmin. So really, at heart, I'm more of a sysadmin than anything else. And I think that kind of shapes my approach to storage. So what is the Shutterfly Image Archive? It is a very specific set of use cases within Shutterfly. So if you don't know, Shutterfly is an e-commerce site where you upload your pictures to us. We look like a cloud of sorts. And then you can design products. You can design books and phone cases and pictures and cards and blankets and posters. Just about anything with a surface, we can put your pictures on them. You can also do really nice albums to give to your friends and family and things like that. So to give you a sense of scale, this time of year we ingest about 10 to 12 million images a day. In Q4, when it's our peak time between Halloween and Christmas, when people are mostly making presents for their families, that can go as high as 35 million images a day, which works out to about 80 terabytes a day. So all I take care of is the images. I don't run the databases. There's a separate set of people that do that with their nice, shiny, pure flash arrays. I don't do the corporate shares, at least not directly. I did loan out a piece of my archive via Panzura appliances to the corporate IT people. So people on the corporate shares are actually using my storage, but they don't know it. But my specific mandate is the images themselves. And it sounds like, well, it's just kind of the archive. But what people don't realize is that it's kind of like air. As long as it's working just fine, you won't even notice us. And just like the networks or the databases, if we stop working, the company is going to stop making money. So when people upload pictures, it comes to us. When people pull those pictures back to design their cards and their books, it comes from us. When they place an order and Those cards and books go out to the labs in Fort Mill in North Carolina to actually be printed on these gigantic digital printers and shipped out to the customers. Those pictures come from us. So if we're down, the company stops making money. So we're not glamorous, but we're important to the company. 90% of our size, and I'll get to our size in a minute, is object store now. We've been migrating over the past 5 years or so to that. It used to be all SAN for the first many years of our archive. Only about 10% is still Fiber Channel SAN, and I'm working very hard to get out of the block management business. I don't want to be in it. 4 separate, fairly clear use cases. We do keep the actual pictures people upload forever, so we have 16 years worth of pictures. For HA purposes, we keep a second copy of those images for 3 to 6 months. So when you upload it, we actually make a second copy right away, but we purge it after a while. Those pictures are about 2 meg on average. They're not giant, but they're not small. When you're on the site designing, you're looking at your album of your photos, you don't need to see a 2 meg file. So we make a little 160 KB thumbnail, and that's what you actually see. And that's when you're going through your album, you're scrolling through your timeline. So we create those on the fly, and we store those. And then we have backups. And backups used to be on tape, but when we get to the size of the archive, you'll see why tape is not something we're going to be doing any longer. So some of the other much larger sites than us, like Facebook and Google, they will take your pictures and store them, but they'll do things to them. We actually have an explicit promise on our site that says we will keep the original picture you give us forever. So I don't have the luxury of doing a lossy compression against them to make them smaller. I have to keep the actual thing. So, and it's free and it's forever. So we do actually have pictures going all the way back to 1999. Okay, and I have 36 slides. I'm not going to read every last one of them. I'll just kind of tell you some of the highlights. This will be posted on the MSST site, so you guys can go look at it later at your leisure. So as of end of Q1, we had 29 billion pictures on file. That's about 65 petabytes of data. 200 petabytes of hardware deployed. That's intended to cover the original archive is 65p, a backup is 65p, plus the data expansion. Our data expansion is about 30%, since we use erasure coding. 50,000 disks, which is not a small amount of disks. But I think the best number on here is actually the one at the very bottom. And so these 2 columns, 2012 is the end of 2012, 2016 is actually the end of 2015. So this is a 3-year spread. So in 3 years, we've grown by 13 billion images, we've grown by 130 petabytes, we've grown by 1 storage admin. And so our average raw hardware to person is 40 petabytes a person. So that's a pretty good number. You can see our growth, it's running about 20% year over year. Last year we took in about 5.5 billion, year before 4.5 billion. This year we're looking at 6.5 to 7 billion. Q1 we took in about 1.2. Q1, 2, and 3 are pretty quiet for us. The big time for us is Q4. It starts right after Halloween and goes all the way through Christmas. People are like, yeah, it's holiday season, let's get our cards out, let's get our Christmas books, let's upload all of the pictures from the whole year, and then let's make products. And so those are that about 8 to 10 week period is really our busy time. So we're just under 30 billion pictures and just about 65 petabytes of data. Let's see. I think the most interesting on this is over the 3 years, you can see that the bottom left, back in 3 years ago, we were almost evenly split SAN and object, and now we are almost entirely object. We've been migrating fast and furious. Object serves us much better than SAN, and we've been working really hard at getting off of it. The only thing that we really have left on it is the thumbnails, because we have a low latency requirement on those. We need to be serving those in about 5 milliseconds, and we can't do that on the object store. At the moment, the object store runs at about 100 to 150 milliseconds. So this is kind of interesting. This is what we've been buying year over year, so you can sort of see when sizes were introduced and were at the right price point for us. Around 2012, 3 terabytes became good. Around 2013, 4 terabytes. We had a little spot in 2015 when the 5 terabyte SMRs first came out. We got together with Seagate and deployed some of those. And then we went like immediately to the 8 terabyte SMRs after that. And the 4 terabytes in 2016 is because one of the use cases isn't suitable for SMR. So we're still buying just 4 terabyte conventionals. And that's the short-term full image archive. We scrub it every 3 months, so it's being deleted. And if you guys know about SMR, deletes invoke a really, really, really steep performance penalty. So we use SMR for the things that we're going to write to until they're full, and we don't use SMR for the things that we're going to be updating. And this is kind of our little in-house joke. If you look at our disks by weight, and then you look at what kind of things weigh as much as a ton, we went through a bunch of different things. There's Sherman tanks and blue whales, and I don't know. The thing that caught our fancy was camels, because they weigh about a ton. So we're at about 33 camels worth of storage at the moment. And if you come to visit our office, we have like we have camels everywhere. There's a lot of camels. So, okay. So architecture. Some of you may know Justin Sotomayor. He is, I think, a pretty well-known architect. He was at Shutterfly. I worked for him, and I took over for him when he left. And he did this great paper 3 years ago here on storage architecture. And so all of our stuff is what he designed and built, and I keep it running. I'm not going to go down the whole list. The only one that I really use all the time is the last one. NEM nodes can be down anytime. So anytime a storage vendor comes to me and says, hey, I've got this great new technology, got this great new cluster, got this great new whatever, I say, great. Is it a cluster? He goes, yeah, it's a cluster. I say, great. Can I have +6 nodes? And he goes, yeah. And I say, okay. And any 6 nodes can be down? I go, oh, well, no, our metadata is stored on these 2, but they're an HA pair. I said, oh, they're an HA pair. What kind of failover do you have? Oh, failover takes over within 60 seconds. I said, 60 seconds. And what happens while the metadata server is down? Well, you can read, but you can't write. Okay. So the part about our site, people are uploading to us constantly. In Q4, our peak times, we're taking in 2 to 3 million images per hour. And so I should go to my CTO and say, guess what? I have a new solution that there's a minor risk that we may not be able to take uploads for 60 seconds during our peak revenue period. Is it okay if I buy this? And neither he nor anybody up the chain from him is going to be agreeable to that. So that's kind of my standard. Is we have this great world. We deploy our clusters in +6. Any of those 6 can be down, and the clusters work. So that's what we want to keep. That's our world that lets us run this amount of storage with 5 people. I started out to do a slide on 1000X, but for our peak period in Q4, 80 terabytes a day at 1000X is like 83 petabytes a day. And I could actually deploy 80 petabytes a day if someone wanted to give me that much money. But I said, okay, that would be like 30 exabytes a year, and I'm not going to keep doing the math on that this year. So this is our kind of overall thing. Architecture, uploads come in. You see those 2 buckets, those 2 columns on the lower parts? Part of our HA is that we can write multiple copies during ingest. So this means that we can have 2 or 3 copies at the time we upload, and we only need to act any one of those for the upload to be considered complete, and then we have back-end jobs that will resync across however many other are needed. This has saved us many, many, many times when one or the other of the primary upload targets has been offline for some reason. The other one just worked. The customer saw nothing. As far as they know, the site was online, working fine. It's more of a detailed view of it. Yeah. Very, very short blurb on CleverSafe, which is the software that we use at present. A very, very, very short blurb on erasure coding, which I think probably just about everybody here knows how it works. And then some of the nomenclature of the CleverSafe technology. But basically, it's storage pools or collections of machines, and buckets are same as an S3 bucket. It's a logical data set. And accessors are the web servers that talk to them all. All of this is shared nothing. So you can have any number of accessors. You can have up to your erasure coded scheme worth of nodes fall down, or be offline, or be in movement, which I'll get to in a couple later slides, and your storage is still working. A couple of misadventures we had with data availability. So this wasn't data loss. This was where, for one reason or another, we temporarily lost threshold. And so enough of the pool was down that fetches couldn't retrieve all the chunks needed to reassemble the objects. But when the nodes came back up, or in the second case, when the nodes were glued back together because they brought the network back up, all the data was still there. And I think that becomes a more dramatic comparison when you think of how storage used to be done on storage arrays with trays and trays and trays of disks connected by fiber, and the thought of just disconnecting a few of the trays for a little bit and just reconnecting it back together, and that your storage would just automatically be there, was something nobody would ever imagine. But because this is node-based parity, the nodes are up, the data's there. So this kind of just gets into my general philosophy about ops. I do believe in being very intentional about managing our environment. I do believe in having a good amount of momentum. You know, this is our environment. We design it, we test it, we build it, we run it. And we look for things that have bitten us, and we try to fix those so they can't bite us again. So some of the kind of overall, someone described this as kind of DevOps-y kind of stuff. Really, it's 190 petabytes and 46,000 disks, but really it's a bunch of machines running Linux with a lot of disks in them. And once you kind of get over the idea of it's storage, don't touch it, you might break it, which is how things were all the way up until, you know, the mid-2000s. Once you realize it's a Linux box, of course you can turn it off and go move it. Of course you can turn it off and work on it. You know, of course there's a software process on it that's supposed to be doing the storage, and it died. Of course you can replace the disk in it. It's just a node. And once you kind of get past that mindset of don't touch the storage, you might break it, to it's a node running storage functions, it gives you sort of, it's kind of freeing. You can be like, hey, I can deal with this stuff. I can deal with hundreds of these. They're just nodes. Let's see. This is actually a true thing. Number 3, once all of the hands-on work is done with the pool, the CleverSafe software is really, really smooth, and it does actually take about 10 minutes to configure a pool. Of course, all that other hands-on racking and configuring and stuff does take time, but they do have it kind of down to a science. We could literally deploy, if I needed to do 85 petabytes a day, I could spin up 4 pools a day in, you know, under an hour if all the hardware was in place. And, you know, assuming that kind of load, I would just have the machines integrated at, you know, some integrator and just rolled in racks, and we would just turn them on and bring them into the administrative networks and be done with it. So a couple of interesting things that we've done. 2012, we bought 5 billion images from Kodak Gallery because they went into Chapter 13. But it was at their data center, and we had to get the data out. And 5 petabytes is not a small amount, so, or 5 billion pictures is not a small amount. So we sent our storage to them. We sent 100 nodes over, which was 4 pools, And we came up with a little Perl script, which would talk to a MySQL database and feed off a list of images and go fetch them out of their storage and stuff them into ours. And we ran that Perl script on the CleverSafe accessor layer, which they sell as appliances, but are in fact just PCs running Debian. And they were kind of grumbling a little bit, but you know, it's our machines and it's Linux, and we can write Perl, and it's not going to knock down your storage demons. So eventually we got up to about 1 gigabyte a second. The isolines that we were pulling the data off of were kind of falling down at that point, so we couldn't go any faster. But we made it in time, in 6 months. There was a hard deadline to avoid an extension fee on their data center space, and we beat that, so good for us. How did we get them back? We turned them off and put them on a truck and sent them back. Which, you know, again, is like, storage, what are you doing? You can't go move your storage. Yeah, you can. You can go move your storage. It's a node. It's a PC with a lot of disks. Even if you lose some of the disks, you've got this amazing extra parity. So, okay, you lost a few disks. Stick some new ones in and let the thing rebuild, and you'll get all your data back. And I think, really, I'm probably going to kind of keep going back to this. It's the new world of sort of mobile, portable, manageable storage. It's not monolithic things that you have to like have people come in and work on and wire it up, and then God forbid you touch it because you might break it. No, it's a set of machines. Now it's over there, and now it's over there, and now it's in the room next door, and maybe now it's in 3 buildings around the campus. And we're running at a 2+1 spread. And if we did a 12+6, and we put 6 here, 6 there, 6 there, and we took that building offline, we would still get our 12 off of the 2 over here, and our data would be online. And it's a very different way of looking at the world from fiber channel SANs and monolithic arrays and even monolithic appliances. So. Another example of this, a slightly different one. So the Kodak one, we sent our storage there, filled it up, we brought the storage back. In this case, the storage was here and it needed to go there, and there was 500 miles away. So, there's a really, really old joke about what's the bandwidth of a truck full of tapes going down the highway. Modern version of that. What's the bandwidth of a truck full of storage nodes going down the highway? Because that is literally what we did. So if you look at this, first column is our current data center, second column is the data center we're going to, week by week by week. All the nodes start there. We took 2 nodes, we have a +6 parity. Any 6 nodes out of any given pool can be down, and we would still have read. Any 4 nodes of any given pool could be down, we still have write threshold. We could still be writing with 4 nodes down out of those pools. So we took 2. We made sure they were healthy, we took down 2, left 2 up, we still added a 2 safety margin. We took 2 out of each storage pool. We had, I think, 24 at the time. Stuck them on a truck, sent them to Vegas, brought them back up on the network, let them resync for a week. Next week, take the next 2 out of each pool, turn them off, roll them out, put them in the truck, send them to Vegas, put them on the net, bring them back up, resync. And so, over a period of 8 to 12 weeks, maybe 16 weeks, the data just moved because more and more nodes were in Vegas and less nodes were in California. But the entire time, we had write threshold on our pools. The entire time, Shutterfly.com was live on the web, even though our data was going. So, you're not going to do that with AMC or Hitachi or, I don't know, whoever else. Right, any of the big monolithic arrays, you're not going to do that kind of thing. They're going to say, oh, buy another one and then spend months syncing over. Like, no, we're just going to move pieces of it because we can do that and it's safe. It's no big deal. People are always kind of interested in some failure rates. So I have some. We're not as advanced as the Backblaze folks on this yet. We're working on it. So I have some lifetime failure rates based on what we deployed and how much has failed. The average fail percent is, it doesn't tell you when during each year of service how many died, so it doesn't give you kind of a real sense. It's just a straight average, which I don't think is all that telling. But those drives from 2011, those Hitachis from 2011, those things are rock solid. We have not lost very many of those over 5 years. So, SMR, we love it for our our archive use cases, which are we write to the disk until they are full, and then we go buy some more disks. We write to those till they're full, and we buy some more disks, and we write to those till they're full. We never delete them. We never update them. So we never invoke the performance penalty. We did this sort of very close coordination with the Seagate and CleverSafe with the 5 terabytes moving to the 8 terabytes, and it was totally safe. We tested and we tested and we tested, and we ended up with them in production, and it was just kind of a natural progression. It worked great. We did lesson learned. One of our admins did not keep track of which pool was on which kind of drive, and decided he would nuke one of the buckets or one of the sort of CleverSafe vaults. As soon as he did it, the percentage of site traffic going to that storage pool containing that vault went toes up. I mean, it just locked up solid. And he came over with like the most sheepish look on his face, and he said, "You know what? Now we know." And I said, "Yeah, we sure do." But because of the way our site is structured, just because you knock down one part of the primary copy doesn't mean you knock down secondary copy. So, okay, great. We couldn't take uploads in copy number 1 and 12% of copy number 1. 100% of copy number 2 was still online taking uploads. Customers didn't notice. I have several slides on this. So again, we have to keep the original image. We can't do anything to it. They're already compressed. So we found this cool tool that this university student in Germany wrote a few years back. We can get 30% lossless compression on it, but it is very compute intensive, and so we sort of had to go on a hunt for compute resources as cheaply as possible. We have a lot of data to compress, so we need a fair amount of compute capacity. Kind of the sweet spot we're looking for is we want to be able to get through the archive in under a year. And so we need 3,000 to 4,000 megabytes a second of compute capacity. And of course, we would deploy that as a distributed farm of workers, hundreds of workers pulling images, compressing them, putting them off to wherever they're going to go. Who has lots of cores to spare? Of course, the big guys do. Who will let you put the data in for free? Of course, the big guys will. Who will not let you get the data back out for free? Those very same big guys. So I do not think that I can go to my CTO and ask for $1.6 million plus compute plus temporary storage to compress these images when there are cheaper ways to do it. So we went through a few variations. This is all over a period of about 2 years. And so where we're at now actually is 5 and 6. So number 5 is, there's a cool article which the link is to. Someone found out that like first generation Xeons are not really that much less performant than the modern V3 ones, but they're really a lot cheaper. So I can build a machine for about $1,000 that'll do 32 megabytes a second of compression. That means for $100,000, I can build a 3,000 megabyte compression farm versus paying Amazon $1.6 million just to get my data back out, regardless of all the money I pay for spots. $1.6 million, 100K. Kind of goes that way. The other part goes back to, our nodes, our storage nodes, our Linux boxes. So I did a survey of all the different CPU types and the machine types. And for the older stuff that might be a little more crotchety, I said, well, let's say we're only going to use one core or one hardware thread of those and not all of them. And there still could be as much as 3,000 megabytes a second of compute capacity just in my storage nodes if I wanted to be a little bit more edgy about it. I probably don't. I probably will stick to just the very most brand new machines with the most threads. I still might get an extra 1,000 megabytes a second out of them for free. These machines already have sitting on the floor, so they're doing nothing. They've already been filled up. I'm not writing to them anymore. They're not getting a lot of reads because that's how our traffic pattern works. Why not put them to work? They're sitting there. So there's that. And there's just kind of measuring, in the pipe of reading through the various layers, reading out of storage through a web layer, doing a DB update or DB lookup, doing the compression, going back through a web layer, going back to a destination storage pool. Where are the bottlenecks at? And definitely the small lines are where the bottlenecks are. So the compression is the smallest part of the pipe. And so I can make that bigger by spending more money, or I can just make it big enough that I live with it for a few months and then it's done. So almost done. So some of the things we're working on, our thumbnails, 5 millisecond median access times right now, and we don't have a lot of traffic. Our total is maybe like 10,000 images a second during peak. But that's the user experience. When people are on their phone looking through their things, the thumbnails are what they're looking at, and we need to be serving those quickly. So we're looking at a startup out of Israel called Weka that they made a low latency SSD-based erasure coded cluster file system. We ran SpecFS on it. We got about a 400 to 500 microsecond latency on 4K random reads. We don't know yet what that's going to look like for us, but if we can get down under a millisecond, that's certainly better than SAN. Certainly the reliability is better than SAN. How much SSD I'm willing to pay versus what I'm paying for SAN now is kind of up for negotiation. But performance-wise, our users will see the images come that much faster. So long-term, 2 to 3 years from now, I would hope that we'll be, the technologies, persistent memory technology will be down to the point where we'll be looking at, low microsecond, high nanosecond ranges. That would be pretty amazing. Like your pictures will you won't even realize. I don't know. I kind of I'll let you guys read this on your own. It's basically it's things that are not quite as much as we would like them to be in our environment, and we're working on addressing them. We have the time to do that because the things just work. We have the right levels of HA that when things break, it doesn't stop the site. I have 5 people on my team. We don't have an on-call rotation. The last outage we had was in October of last year, and it was in the SAN, the 10% of our storage, because our own site code was DOSing us. The last outage we had in the object store was a year before that, because we hit connection limits on our accessors due to a software, a memory leak. So we have time to work on stuff because we're not always fighting fires. We deploy the same kind of storage. We partition the traffic. We have multiple layers of HA. And so the thing just kind of runs. And that's why, we get 40 petabytes a person, because we're not running around all the time, nights, weekends, everything. So, and the last interesting one, I think, is where did old disks go to guy? So we're doing the migration, the 2011, 2012 disks. There's about 16,000 disks. It's about 30 petabytes. And that's those 5-year-old Hitachis that only 10% have died of over 5 years. So why would I throw them away? 30 petabytes? No. So I'm going to put them in new chassis and go with an even higher erasure coding scheme so I can tolerate more losses. And I'm sure eventually they're all going to start falling over a bit, but I might get another 2-3 years out of them. And I can use them for a less critical use case. Maybe somebody wants their own copy of the image archive. Maybe they want 5 petabytes of data. Like, here, go use this. Maybe they want to do a bunch of, metadata extraction off of the images, and they want some place to store it. I can say, here, this is the stuff I have. It's not the most performant, and we'll keep an eye on it. At some point, it's going to go toes up, but it's free. We've had it. We paid for it 5 years ago, and it's still useful. Go ahead and use it. So that's what we're doing, and that is it. There we go.